More examples on extreme values. So find the extrema of the function f of x given by 2x cubed minus 15x squared plus 24x plus 7 on this interval 0 to 6. So you start by finding the derivative of the function to get the critical points. So f prime of x will be given by 6x squared minus 30x plus 24, which is the same thing as 6 into x minus 1, x minus 4. So the critical points or critical numbers satisfy this derivative must be 0. Therefore, the critical points are x equals to 1 and x equals to 4. So therefore now we test. So when x equals to 1, f of x will be given by f of 1, which is 18. X equals to 4, then f of 4 will be given by negative 9. When x equals to 0, remember we test both the critical points and the endpoints. We have f of 0 will be given by 7. And then x equals to 6, then, so remember this is a critical point. This is also a critical point. This is an endpoint. This is also an endpoint. So f of 6 will give us 43. Now, when you compare all these values, we see clearly that negative 9 is the least value, so that would be the minimum. 43 is the maximum. So therefore, we conclude by saying, therefore, the maximum value of f of x on this closed interval 0 to 6 is 43 at x equals to 6, and the minimum value of f of x on this closed interval 0 to 6 is negative 9 at 4. Negative 9 at x equals to positive 4. So that is how we work out that problem. Another example, find the extrema of f of x given by 1 minus x minus 1 raised power 2 over 3 on closed interval from negative 1 to positive 2. So the first thing, as usual, we get the derivative. So we'll have the derivative of this function will be given by minus 2 over 3 x minus 1 raised power minus a third, which is the same as minus 2 over 3 into x minus 1 raised power a third. And then critical points are obtained by setting the derivative of the function equals to 0. And then this has no solution, since we'll have 3x minus 1 equals to 0 implies minus 2 equals to 0. This doesn't make sense. So f prime of x equals to 0 has no solution, because f prime of x is never 0. However, f prime of x does not exist at x equals to 1, because this denominator would be 0. So therefore, there is a critical point at x equals to 1. So this is how the graph of that function looks like. This is how the graph of the function looks like. So this one is -1. So this is 2. So this is the maximum point and this is the minimum point. So we test now, have the testing now for the points. Now we have the point 2. So critical points x equals to 1, f of 1 will be given by 1. Now endpoint x equals to -1, we have f of -1 will be given by -0.59 roughly, and then this is the left hand side endpoint, right hand side endpoint, x equals to 2, f of 2 will be given by 0. Now when you compare all these three values, we see that this is the minimum and then this is the maximum. So therefore we say the maximum of f is 1, which occurs at x equals to 1, and the minimum of f is -0.59 at x equals to -1. Lastly, another example. Find the extrema of f of x given by 2 sine x minus cos 2x on the interval 0 to 2 pi. So as usual, the first thing is to get the derivative of the function, and the derivative of the function will be 2 cos x plus 2 sine 2x equals to 0. So this will help us to get critical points. Now, this equation can be written as 2 cos x plus 4 cos x sine x equals to 0. Remember, sine 2a is the same as 2 cos a sine a. So we are using this identity. So this will be the same as 2 cos x into 1 plus 2 sine x equals to 0, which tells us that cos x equals to 0 or sine x equals to negative a half. Now, when we solve these two equations, so in the interval 0 to 2 pi, cos x equals to 0 when x equals to pi over 2, and when x equals to 3 pi over 2. And then in the interval 0 to 2 pi, 1 plus 2 sine x equals to 0 when x equals to 7 pi over 6, and when x equals to 11 pi over 6. Please confirm this. So therefore now all these are the critical points. So therefore now we'll start testing now. So testing. So start by left endpoint is x equals to 0. So f of 0 is -1. And then critical number x equals to pi over 2. Then f of pi over 2 will be given by 3. Another critical number is x equals to 7 pi over 6. So f of 7 pi over 6 gives us -3 over 2. And then another critical number, x equals to 3 pi over 2. The value of the function at 3 pi over 2 will be given by -1. Another critical number, x equals to 11 pi over 6. We find the value of the function at 11 pi over 6. That is -3 over 2. And then lastly, the right endpoint is given by x equals to 2 pi. So the value of the function at 2 pi will be -1. Now, if you observe all these values of the function of the critical points and the endpoints, we see that this is the minimum value. And then we have also this one is a minimum. And then the maximum occurs at pi over 2. So this is the maximum. So for this case, we have 2 minimum points and 1 maximum point. So we say, therefore, the maximum value of f is 3 at x equals to pi over 2, and the minimum values of f, the minimum value of f is -3/2 occurs at x equals to 7 pi over 6 and x equals to 11 over 6 pi. So that is how we find them. Thank you.